Okay, I see the recording going. And let me just get a few things set up over here. Okay, everybody, welcome to Module 2, Session 2 of the great Arduino series here at the FAU Libraries. My name is Mahesh Nilakanta. I'm the Director of IT here at the FAU Libraries. And let me switch to the FaceTime camera so you can actually see me. Okay, hello. And I hope you had some time to look through the previous video, learn about what Arduino is, go at least, if you haven't gotten the little Tinkercad kit, the thing that we went over 2 weeks ago. And I hope that you're at least able to try the little example that you were able to see in the video. And what I want to do is basically start off with any questions that we might have from the previous session. I want to give at least 5-10 minutes to that. And then what we're going to focus on today is just a little bit about electricity, and then go into the example that we saw last week, but with a little bit more detail. We're just going to modify the code a little bit. But most of today's session is actually going to be about the Arduino programming language. Obviously, the benefit of what we're doing is that we want to actually program that little Arduino that we have and make it do different things. But in order to do that, you have to really learn how to use the language. It's a variation of the C or C++ language that comes from decades ago. They've tweaked it to make it a little bit easier. And initially it may be a little bit daunting, but I can tell you that just playing with it, you can make a lot of mistakes, and it forgives you very easily. Worst thing that can happen is you create a fire and burn down your house, but other than that, everything else should be fine. So we're going to go over the language itself, and then we're going to use what we learned to try and make the blinking lights example that we saw do a little bit more fancy stuff. So I think we have the chat capability, and so if you do have questions, you can chat away. Let me try and actually get to see if I can switch my video to that. I'm going to stop sharing my video. Trying to get my chat window open. All right, here we go. There's my chat window.
Mahesh, just wanted to make sure that you see the first question coming in. Is it safe to connect devices or wires while the Arduino is turned on?
Yeah, it most of the time it is. So let me actually show you what I have. You can still see my video, right? Okay. So I'm going to stop sharing so the video looks big. And Tanessa, can you confirm that the video looks bigger now?
Yes, it is.
Or taken up? Okay, great. So here's two things that I use in my own setup over here. I'm going to move this camera over. Over here, let me try and point it there. You see that little, this is actually a USB hub. I really like this hub because it's got these little power buttons over here. If I press that power button, you can see that little blue light turned off next to it. And now I can power it back on. So the first thing I normally do whenever I'm working with the Arduino is it's very easy for me to turn this off and turn it on. It's a really nice little utility. It's about like, 15 bucks on Amazon. This happens to be a USB 3.0 hub because my Mac happens to have USB 3. They do sell cheaper versions as well. That cuts the electricity from going from my computer, because that's actually, right now, my computer is actually being powered. My Arduino is actually being powered by my computer. So let me run that. See that little wire right here that's coming through? This is actually powering the Arduino. So the question asked is really, can I disconnect wires? And yes, I'm actually going to do it here live, and I'm going to remove it, and I'm going to plug it back in, right? And there we go. Everything is still working. The light is still blinking. So in general, the answer is actually no. You shouldn't disconnect wires while you're doing it, because there are two things that can happen. One is you could be sending voltage to some sensitive electronics that can burn the electronics. The other is actually something called electrostatic discharge, which is basically actually electricity that could be in your body itself. You get that when you rub a balloon and you try and touch it, or it sticks to you. So you should actually do one of two things. You should actually wear something called an ESD adapter that connects to your body. You see electricians work with something like that, so you're not touching this like I'm doing right now. But here's the thing: you can buy this thing for $4. If you burn it, it's only $4. It's not too bad. You don't lose too much money. I've never burnt a device in the years that I've been using it by disconnecting and connecting wires. Now, everything we're doing is low voltage, meaning DC voltage. We're not connecting any of this to the AC mains, okay? There's a big difference when you're working with alternating current that comes from your wall outlet. We're not doing any of that right now. That's a completely different ball game. So, and definitely don't play with AC electricity like that. Let me switch back to my Q&A questions here. Any other questions, anybody? Where's the background music? Yeah, I gotta learn how to do that. Okay, all right, good. So more time for us to do the class. Okay. All right, so let me just move this around, get this set up nicely so you guys can see everything. Okay, and start sharing my screen again. Okay, great. All right, so before we get started on things, I just want to make a small detour on what electricity is, right? So I found this nice little description. Electricity is the flow of electrons around a circuit. Okay, so what does that mean? So we have a battery here that has energy in it. And when we connect a circuit, and remember, a circuit basically literally comes from the word, circular circuit, right? You create a circuit that goes around. It creates a flow of electrons that goes from the negative side up to the positive side. And when you close that circuit, if there's a device in between, that electricity is going to cause something in that device. And what I'm going to show you here is the most basic circuit that you see actually on my diagram. So here is, many of you have seen this. It's a coin cell battery, basically something that you find in small electronic devices or like watches back in the old days. And then over here is an LED light. Now remember, I told you the LED light has two parts to it. There's a positive and a negative side, right? And what I'm going to do is create a circuit. First time, it's not working. Why? Because an LED light can only work when the positive is connected to the positive and the negative is connected to the negative. So I'm going to flip this. Voila. So I'm actually creating a circuit here. This circuit is very simple. It's just going from the negative side to the positive side. A flow of electrons are going around it. Okay? That flow of electrons is actually going through a little piece of electronic device in there called a light emitting diode. What is a light emitting diode? It's a diode that is excited when electricity goes through it and emits those electrons as photons, and so you see the light. Diode is a device that only sends electricity in one direction. I'm simplifying this very much, but that's all you kind of need to know to understand it. So what do you see over here? And I can start this device. Actually, it's already running. The Arduino that we built that blinked an LED. Let me share my screen again. Is basically this code right here. It sets up 2 pins and then turns a pin on or off depending on what we do. High means turn it on, low means turn it off. I've simplified that circuit. I've removed one of the LEDs just for the sake of explaining what's going on. It's the same circuit that we saw before, except what I've done is I've put what's called a multimeter that's measuring the voltage. It's connected on the negative side and the positive side. And let me make it bigger again. Over here is the negative side. Over here is the positive side. And if you look carefully, what we're doing is blinking the LED every 3 seconds or so. And take a look at my multimeter. This is actually measuring voltage. And you can see the voltage is 0. Oh, the voltage jumps up to about 3 volts, 2.78 volts, right? So what the Arduino is doing is it's basically doing the same thing like a battery does. It's turning on electricity between the pins that are connected here and here. Specifically, this pin right here, it's turning it on, which causes the flow of electricity come through it and light it up. And so in the most simplest example here, the Arduino is working like a battery with a switch on it. It just so happens that that switch is turned on and off with code. Okay. Now, if you recall, last week I also showed you, sorry, 2 weeks ago, I also showed you that you could write the same, build the same circuit in the Tinkercad environment. And so I'm going to bring up my browser, and I'm going to Tinkercad. I'm going to my circuits. I'm going to load that circuit up. One of the nice things with Tinkercad is it lets you simulate an Arduino Uno. So here's the same circuit I have. If I look at the code, in a second. Here's the same thing. Of course, this is blinking every 1,000 seconds, but I can change that to 3,000 milliseconds. Oh, it's already saved, so I don't want to change anything there. And if I start the simulation here, check it out. Every 1 second, the voltage is going up and down, up and down. Now, why is this showing 4.7 volts versus my real world simulation 2.6 volts? I'm using a different resistor. The resistor job in life is to lower or protect the circuit that it's connected to. The resistor I have in my circuit is a higher resistance value, and so there's less volts going to the LED light. Okay, that's just a quick detour. So I hope it explains what we were doing originally. So next up, what I want to do is I want to show you a quick demo that I've modified. So everybody knows Morse code. Well, you might not know Morse code, but you might know of Morse code. The most common example that everyone knows about Morse code is how to send an SOS signal, which is basically ... dash 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 ... And so I've modified our blinking LED light to do a little bit of Morse code. In this case, it's going to do 3 dots, followed by a pause, followed by 3 dashes, followed by a pause, followed by 3 dots. And we're going to go over what these actually do. And here's a small video that shows it. So you can see ... dash, 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 ... Give me a second while I bring up my chat window. Fortunately, my chat window keeps going away. Janessa, since you're still on the call, if you see a question, just interrupt me because my chat window keeps disappearing. And then the code over here, we'll be going over it at the end of the class, but it uses some constants or static values. It uses something called functions. And then we're going to see also how to use some conditional clauses in a very short while. Okay. Okay, let's go ahead and turn that off. All right, so what is the Arduino language? As I mentioned earlier, it's really a variation of the C or C++ language. The core language has, of course, some structure associated with it. It has these things called variables and constants that are of a certain type of data types. It has this concept of functions, which allows you to break your code down into smaller workable segments. Again, a lot of what I've built on is actually I've taken and copy pasted a lot of examples from the Arduino reference as well as the Sparkfun Tinker Kit tutorial. So you'll see a lot of stuff where I reference other locations. In this case, this is a reference to the actual language reference. So if you go to this link, you'll actually see the language reference over here, and we'll be going over this today. And of course, just a reminder, all of this, the slides and everything are available on my GitHub Arduino page. So as we progress in this class, I'll be uploading more code. The actual slides will be updated after each course is done, after each module is done, so that you can get the updated PDF there as well. And then I'll be also adding some videos and stuff over here through GitHub. Okay, so let's go back over here. And lastly, no language is good by itself. What makes Arduino and the Arduino language very powerful is this concept of libraries. Libraries are groups of functions or functionality that let you do all kinds of things to using the Arduino. There are libraries to communicate with other devices, to process data, to store data, for example, on a micro SD card, to turn on and off servos, for example, to display on LCD displays, to take input from sensors like temperature sensors or light sensors, to turn things on and off. Timing is basically like when you want to like delay. Those are examples of timing functions, libraries. All right, so there's a lot of stuff that a language can do, and it can be overwhelming sometimes, but ultimately doesn't matter whether you're programming in C, Java, Python, Ruby, whatever language you want. There are some very basic functionality that goes across all different languages. What makes some languages easier to work with than other languages is the readability. And C falls somewhere in the medium range in terms of readability. From my own experience, the most beautiful language that I've ever come across is a language called Ruby. And it's just an easy to read language that if you look at somebody else's code, it just makes a lot of sense. One of the hardest languages for me to read is a language called Perl. It just looks very difficult when I'm trying to understand someone else's code. And C is somewhere in between. And you don't have to learn too much about the language. It can be overwhelming, but there are very few statements for control, and we'll go over these. Things like arithmetic operators, comparison operators, Boolean operators are very few, and a few compound operators that we'll learn. Things like pointers and bitwise operators are more complex, and maybe we'll do that in an advanced class. But for now, we're going to focus on just the easy stuff. As I mentioned, there are variables. Variables are used to hold data, and we'll go over them very shortly. And there are different types of data types. For example, you could have integers or float, which are decimal places. So if you want to measure temperature, you really want to measure that it is 32.5 degrees Celsius. And there's a big difference between 32.5 degrees Celsius and 32 degrees Celsius. So those decimal points make a huge difference. And then Arduino, the language itself, also comes with a core library of functions. We already used one, and if you look at our code here, we actually use the function called pin mode, a function called digital write and delay, and these are basically built-in functions that tell the Arduino to do something. There's a lot of code behind each of these functions, and the benefit of having this do it for us is we don't have to write all the code behind it, and that makes functions very easy, very beneficial when we're trying to write code. A good example is, for example, if you're trying to where's a good one here, like compute the absolute value or the square root, right? You don't actually have to know the math behind how to compute square root, or to do trigonometry to compute the cosine, sine, or tangent of a value. All right, so just a pointer again. I owe a lot of what the next set of slides are. I've just taken them straight off the Arduino language reference because they do a good job of it. No need for me to replicate it. So let's talk about control. Oh, sorry. Yeah, in control. So real quick, we have this concept of functions, which we'll talk about very shortly, but we also have the need to document our code. When you're documenting your code, it's called commenting your code. And you use these little slash star and star slash to denote something that's in comments. You can also prefix your lines of code with 2 forward slashes, and that will basically comment out that line. And so you can write some comments and annotate your code using these slash star, star slash, or 2 forward slashes. You'll see in most of the Arduino code that you write, these little semicolons. The semicolons terminate, tell us when the line that we've written has come to an end, basically like an end of line delimiter. And it's very important because if you don't do that, the compiler will give you an error when you're running your code. Lastly, there are these things called curly brackets or curly braces, depending on where you're from. The curly braces allow you to denote a section of code, specifically if you're doing something with functions or if you're doing something with loops or conditional statements, which we'll talk about very shortly. All right, the most easy to use conditional statement is the if clause. It's actually an if then else. The if basically checks for a condition. For example, you could say if the switch is on, if the temperature is greater than 5 degrees Celsius, if the motor is on. Those kinds of are examples of conditions. And so if a certain condition is true, perform a certain set of statements. In these examples, for example, we have if a value is greater than 120, then turn the pin high. And it's very easy to create conditional clauses like this and make your code do different things based on the circumstances of your current environment. Well, you could also do something where if the opposite of the condition happens, so we just looked at if condition, well, there's also an else condition. So in other words, suppose you say, if the temperature is greater than, as an example here, 70 degrees, then shut down the system. You could turn off the motor or something like that. But if the temperature is between 60, is greater than 60, but not greater than 70, then you could say like, hey, something is getting a little bit warm. And lastly, if the temperature is less than 60, then you could just say, hey, just do whatever you're normally doing. So this concept of an if else or if then else, you'll hear different people say different ways, is the most basic coding construct that you'll use in a lot of what you're doing in Arduino or in any other programming language. It's often how we operate ourselves. If my stomach is hungry, then go eat. While statements are loops. A loop is when you want to do something over and over and over again until a certain condition is met. So for example, you may want to keep the motor running until a certain temperature is reached, or you may want to leave the LED on as long as there is no light that the light sensor is picking up. So you would basically, anything that happens within the curly braces of a while statement keeps running until it's done. The example down here is actually using something with a variable, which we'll talk about shortly, is so long as the value of that variable is less than 200, we do something. And these are really important. For example, if you want to, you'll see in the example that if I want to blink something a few times, I could just use a loop statement. The do while is almost exactly the same as the while statement. You can see the while says so long as the condition is happening, do the statement. A do while says do the statement while the condition is true. The difference is very minute but important. In this case, it's possible that this condition will not be true, and so the statements will never be executed. In a do while, it has to do the statement at least once and then check the condition. When you write code, you might not see the reason why you might want to do this, but there are very specific cases where sometimes you want to do something at least once. A for statement is another type of loop. A for statement says do something from a certain starting point to a certain ending point. And so in this example that you see down here, this is a loop that does it from 1 to 255, do something for those 256 times, I guess, because it includes 0 times. And you'll see an example of for. There are some ways to get out of a loop. suppose some threshold is reached and you don't want to keep looping, you would use the break statement. Another example is the continue, which is suppose a condition hasn't been met and you want to just skip the rest of your code that's inside your loop. You could use the continue statement. And when to use a break or a continue or a for versus a while depends on the circumstances. As we go through this course, you'll see each of these being used in different examples, and then you'll start learning to use different types of control structures for different use cases. The purpose of this is just to introduce you to what they are. Now, if you look inside these statements, you'll see these like greater than symbol, less than symbol, less than, equal to. These are called comparison operators. So a comparison operator is basically very basic algebra. You can compare two values. You can check whether they're less than or greater than each other, or less than or greater than equal to, less than equal to, or greater than equal to. These are important when you're comparing values, say from a sensor, if the temperature is greater than a certain value. So here, for example, if X is greater than Y, then do this stuff inside the curly braces. This one says if it's less than or equal to Y. This says if it is equal to Y, meaning the two values are the same. And this says it's not equal to. The exclamation point is a very common term for the inverse operator, which is often called not. And so if you read this in English, you would say if X is not equal to Y. Another kind of operators are math operators. This is basically what you think they are, which is addition, subtraction, multiplication, assignment, or division. So for example, if you needed to get the temperature value, you would read a sensor value and assign it to a variable. If you needed to add two values together, you could use the addition or subtraction. You could use the multiplication operator. And if you go back to your algebra, you remember the precedence of multiplication over addition. So this is very simple. It convert from Fahrenheit to Celsius. You take the Fahrenheit value, multiply by 1.8, and add 32. Versus if you want to convert from Fahrenheit, this is from Fahrenheit Celsius. Wait, oh, I made a mistake here. This is supposed to be Celsius to Fahrenheit. So this would be reversed. And of course, you have to put the parentheses to denote the precedence of the minus over the division. I'll fix that before I publish this again. Another type of operator is the Boolean operator. The Boolean operators are used to compare, to see if two different things are happening. For example, if this section and this section are true, then do this. Or the bar, two bars by themselves, is read as or. If X is greater than 0 or Y is greater than 0. The not is exactly, it says if not X. If X is not true, then perform a certain statement, set of statements. There are a few more operators here called compound operators. These let you make some steps really fast. For example, if you need to increment X by 1, you can add and make them grow really fast. Without having to do a lot of math. You don't have to say X equals X plus 1. You could just say X plus plus. But we won't go over this because these are not needed for this session. So I've been going over some things called X and Y and Z and TC and all that. What are they? They're called variables. Variables are of type are values that can be of certain data types. What are data types? Their data types are used to define the type of information that you're trying to compute, acquire, modify, store, or send. Meaning, if you read a temperature, if you read a value of a motor speed, if you read the light value, the lumens of something, all of those need to have a value. And they could be integers, they could be characters, they could be floating or rather decimal values. They could even be strings, which are characters, an array of characters. And so when you have these data types, you would create a variable of a certain data type. Variables are basically values that are of a certain type of data type, and they're used to store the value that you're trying to keep in your program. Now, there's a very important thing about variables, which is that the value that they have can change over time. So for example, here I have A equals 10, B equals 3.14159. Here's an example of a string that's holding the value FAU. Now, these values can change over time. So I could change the value of A from 10 to something else in the future. And that's very important because if I'm reading temperature, I need to be able to know that the temperature changes and get the new value of the temperature. Here's an example of using variables and using other variables to multiply them and get their value into a new variable. Now, constants are just a small variation of variables, except the value of a constant cannot be changed. So for example, in the previous, I have float pi equals 3.14159. Really, pi never changes. So it's better to put the word const before it. Why would you use constants? To prevent you from accidentally setting a variable that's not supposed to ever be changed. There is a slight variation of it called predefined constants, we use the word high and low. Those are predefined constants that come with the Arduino language itself, in the Arduino programming environment. The last section of this is really something called array variables. Arrays are basically variables that have a list of values. So suppose you needed to keep a bunch of integers together. So for example, the different pins that you're using on your Arduino, or if another example would be a sequence of characters or a string, as we call them, you would use an array. So an array just keeps all these different values, and all of those can be accessed using something called an index value. So for example, here, you're creating a 10 array, 10 integers in an array called myArray, and you're assigning these values into it. And you could access each of those values by the index itself. Now it says 10, but indexes are starting with 0. So this is actually myArray 0 through myArray 9. So if you try to access myArray 10, it's actually invalid because indexes start with 0. This is a very programmer-centric issue. Some languages start with index 1. Most languages start with index 0. All right, so now we're coming to the tail end of this, functions. So I'll let you read this before I continue, and I'll read it back to you. Okay, so functions are very, very important in our environment. Why? Because they break down our code into manageable segments. Oftentimes when you write code, you'll start seeing that you're writing a whole bunch of code inside the setup or inside the loop area of Arduino. And ultimately you want to say, like, I need to break this down into something that's easier to understand or that I can focus on. In fact, the setup and loop are the main functions that we have seen already. And the example that I'll show you is where we do some of those things in other functions that you don't have to put everything inside the loop. This is very important because when you are breaking your larger task into subtasks, it really makes your code easier to read. It also lets you split your code writing up with somebody else, so somebody else could work on a certain part of your code. We've seen setup and loop in the original example that we used to blink LED lights. The setup is called when the Arduino first starts up. So when you first send power to the Arduino, or if you press the reset button. So when you send power in through the USB port, or if you press this little LED, this little push button over here, the Arduino will run the setup function. Once it's run the setup function, it keeps calling the loop function over and over and over and over again until the Arduino is turned off or some error happens in your code where it needs to stop. It's not able to proceed anymore. You can also use something called user functions. So if you recall earlier, I went over the SOS example, ... Well, I could blink the LEDs using the digital write high or low to turn the LED on and off. But what I did instead, oops, 1 second, is I created a function called dot blink, which is basically blink a dot. And that basically turns on the LED, waits for a very short delay, and then turns the LED off. I created a dash blink, which turns on the LED, waits a different amount of time, and then turns it off. The difference between dot delay and dash delay is a few hundred milliseconds because our eye needs to be able to pick up the difference between a dot and a dash. By doing that, I can, instead of creating this section of code, these 4 lines, instead of doing it in each of these 3 lines, I'm able to just call this function, which runs this code, returns back, calls it again, returns back, calls it again, returns back. And then I use the delay just to wait between each character, and then do the dash and then the dots. So you can see that instead of doing this digital write high and low and the delays in between for every dot, I instead created the function to do that work for me. The core library itself contains a bunch of functions that I've shown you earlier. You can go into the reference section and read what each of them does. And so here's an example of a library that's not in the core library. This is basically something that's an Arduino that's connected to the server, a servo, which is basically a device, sorry about that, a device that can turn left or right. In your Tinkercad kit, you should see a little servo. Let me try and find it in my kit if I didn't already move off somewhere. I may have taken it out. Yep, I can't find it. It's, oh, there it is. This is a servo. It's got a little, stop sharing. It's got a little axle right over there, and it can actually turn left or right, and you can control how much it turns left or right. It's often used in little robots to move sensors and stuff like that, or radio controlled cars to turn the wheels left or right. Share my screen again. So this is an example of turning a servo on and turning it 180 degrees and turning it 180 degrees back. And by using the Servo library, you don't have to worry about all the electronics and signaling that goes on to make that servo turn left or right. By making it very simple, by just calling it saying, hey, turn the degree that you need to do, you save a lot of time and debugging trying to figure out how it works. Arduino comes with hundreds and hundreds of libraries for hundreds and hundreds of different types of devices. And the power, that's one of the real powerful capabilities that Arduino will bring to the table. Second. Okay, so we've learned all that. Let's put it together. Remember that blinking LEDs? Let's put some code to it. So here's the code that I actually wrote. What I did was I took the example that I had in the beginning and I said, let me add a few things to make it a little bit more fun. So I used constants. In this case, I'm using a slight variation of a constant. This is actually not a variable, but you can go and take a look at what number define is in the Arduino reference, and you can see what it does. If you have a question, definitely be sure to ask me next week. There's a very small but important difference between using a number define and a constant, which is constant. So what I'm doing is I created a variable for LED pin. I called it 13. I have a message here called AB. That's the message I want to create in Morse code. The dot and dash blink that you saw earlier, I just renamed them to just calling them dot and dash. But inside, they still do the very same thing. And if you notice here, there's something called dot delay, and here called dash delay. And if you go up here, you can see that I defined dot delay to be 200 milliseconds and dash delay to be 350 milliseconds. Two other ones, which is the delay between each character, is 500, and the delay at the end of the message is 1,000 milliseconds, or 1 second. And so if we look at the main code itself, we see there's a setup function. We've seen that many times. I've added a small piece of function call here called serial begin 15,200. We haven't gone over it yet, but I'll show it to you shortly. You can send information back to your computer from the Arduino using what's called print statements. And in order to send that back, for those of us who are old enough, there's something called a baud rate. A baud rate is the speed that a computer talks over a serial device. Way back in the 60s, 70s, and 80s, we used these things called modems to access other computers or the internet. And we would have a modem of a certain type of speed. Ultimately, this just comes down to how many bits per second we can send over the device. Now, obviously, the Arduino doesn't have a modem, but what it does have is a USB interface. That USB interface actually shows up as something called a serial device on your computer. And so we set that speed of that serial device to 15,200 bits per second, or baud. We already know this. We're setting the pin to be output. I've created two variables, one called an index and one called letter. And here's where I'm able to send some information back. This is going to probably help you all throughout your Arduino career. You're going to have problems with your code. You don't know why it's not working. The best way to know what's going on is to print some information back on the debug console. And we'll see that happen just shortly. And then we create a for loop. So remember, a for statement is used for loops. We use an index counter. The index counter goes from 0 to, we're using a function call called size of message. You can almost tell what this does. Size of message. Well, message is 2. So most likely size of message is 2. So why do we go -1? Remember I told you it starts with index 0. So 0 and 1. So 0 less than 2 or 1. So it goes to 0 and 1. And then we increment by 1. We get the value of the message at that index. We print it out to the debug console. And then we check, is the letter a capital A or a lowercase a? A lowercase a, I happen to know, is a dot dash. That's what it is, or dot dash in Morse code. The letter B is dash dot dot dot. The letter S is dot dot dot. The letter, oh, look, I have another bug here. It's supposed to be O here, dash dash dash. See, this is supposed to be uppercase O and lowercase o. And then if we don't know what the character is, then we just skip it. And then we wait for a little bit of time for the character, for the delay. And then we go back and do the loop again. So one really important aspect of this that let me try and move over here. Have this disappear, that slide. 1 second. Okay, there it is. End of message delay all the way on line 75 there. That's between pausing between each time we send the message. So I'm going to load that code. Here it is. Okay. And I have uploaded this into my GitHub page. So if you go to Morse Medium, there's the code over there. So you can actually go over here. If you need to download this code, you can actually click on the raw right there. And you can see it's right there. And you can right click and you can choose save as right there. And then you can save it to your own computer. Or you can try and write it as well from scratch, which is a good way to learn. Back in the old days, we used to have magazines where people would have all this code and we would have to type everything in by hand. I mean, like pages and pages of code, and hope it works. Back in the Apple and Commodore and Atari days. Okay, so ready to try this guy out? You can see the code here. You can see my little Arduino device over here.
Hey, Mahesh.
Greg found the SNO. Yeah, go ahead. Yeah.
I saw the message from Gary about changing your S2.
Let's go fix that code. Thank you, Greg. Right there. Welcome to bugs. For anybody who's interested, a bug is error in your code. Why is it called a bug? That's a great homework. Google, why is it called debugging, or why is it called a bug? And you'll find out about a certain admiral who happened to make that terminology come about. At least I believe that's true. So, all right, everybody ready? So I have some comments here, by the way. I forgot to completely mention that. /. I have some comments in here. I got a lot of cool functions. I got a little loop statement, some conditionals, some Boolean operations here, comparisons with characters, function calls, everything is in there. So let's go ahead and click on upload. So just a reminder, if you haven't, here's my, if I go to my Arduino and I go to tools and I can check my port, make sure, oh, if you notice, oh, on my Mac, I don't see my port. And I'm actually going to do this so you can see an error. Remember that I turned off my Arduino? Well, I was pressing that button. Well, it's not connected. Watch what happens when I click upload. This is actually good. Bam! Oh, it couldn't connect to my device. Look at that, can't open device. Most likely that means that I haven't plugged in my Arduino. I just plugged it in, and if you notice, it just blinked. Now, if I go back to my tools, go to port, you can see it already connected. This is a very common problem. Did you plug in your device? So now I'm going to try upload again. Here it is. Here it's uploading. All right, all done. Now, this little thing right there, see that little, what's that called? Magnifying glass. Click on that. Oh, wow, look at that. Debug information helps me understand what my program is doing. Remember the code here? The part where it says printing, and then it prints what message it's printing, prints the length, and then the actual letter that it's working on. Okay. And I'm just going to stop my sharing so you can kind of see this in the big screen. I need to see it on my video as well so I can see what you're seeing. Stand by. There it goes. So we're printing A and B. So A, one second. A is dot dash and B is dash dot dot dot. So A is dot dash, B is dash dot dot dot. Dot dash dash dot dot dot. Okay, now let's make a small change to our code. Let's go ahead and let me share my screen again. Okay, let's change our message from AB to SOS. All right, I'm going to save it. I'm going to upload it again. Let's look at our code. Notice what it says now, printing SOS, length 3, SOS, SOS. Let's look at my screen on the big screen. There it is, dot, 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 dash, dash, oh wait, dot, 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 dash, 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 dot, 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 dash, 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 dot, dot, dot. And you can, if you are watching my multimeter over here, you can see how fast the voltage is changing over there. It can't even keep up with the change because it's happening so fast. If you have an oscilloscope, oh, those are a lot of fun. Then you can actually see this on a digital display. But that's for another day. Okay. All right. Let me share my screen again. Okay, there we go. All right, so we're at the end of today's lesson. So what we did was we covered the Arduino language. We went over the control structures, variables, and constants, and things like Boolean operators, math operators. We went over the ability to modify your existing code and add some of this functionality using what we've learned using functions, constants, conditional clauses, loops. And then we also modified our code to do something different. If you do end up doing this, why don't you, as a take-home, why don't you go look up the Morse code and extend the functionality to support all of the 26 letters of the alphabet. And then you'll be able to put whatever message you want on here and then have it blink it out, right? You just have to figure out how do you extend this, and you can kind of understand what you need to do by just looking at it and see if you can support more characters. You only have 26 times to do this. There are other more optimal ways to do this. We haven't talked about switch statements or arrays where we could use this in a different way, where we could store what the letter A looks like. But that would be a good take-home exercise for you to do. And for the next module, we will be going back to the Tinkercad kit, and we'll be building the I believe it's the potentiometer and the light sensor kits next week. And we'll be looking at the code that uses that and using the libraries for those devices. So we've come to the end. So please ask questions on what you've seen so far. On my PC, someone said on my PC, I had to change my baud rate to 9600. So if you do not do this, there's a statement in here where it says serial begin 15,200. There's another section over here that says 15,200. Be sure to set that baud rate to match what you do. Okay, 9600 just means 9600 bits per second. So I just happen to use 15,200 because I know that that's the speed that the Arduino actually, if you look over here, when the Arduino compiler is uploading the code, somewhere in here, it actually should say that the speed it's uploading it at. I thought it did. But yeah, so yeah, if you notice, let me actually do that. Here's what happens if you accidentally have the wrong baud rate. See that junk that's coming out? That's because you're trying to read at a certain speed and the Arduino is sending it at a completely different speed. So if you see junk like this, make sure your baud rate matches the speed that you're listening at, right? It's like trying to understand someone who's speaking really, really fast, but you're trying to understand and have them speak to you really, really slow. How do you get additional compile? Oh, there's a couple of questions here. Sorry. I missed the first session. I was wondering if the recording and where could I get caught up? Yes. So if you go to the FAU Libraries YouTube, to go to YouTube and search for FAU Libraries, we keep all of our sessions here. So if you click on that, we have other webinars, for example, on from a technical perspective, we have on 3D printing. In fact, we'll be doing one on 3D design very shortly by our very own Crystal from our ITS group. So right here is the webinar series for session 1, and you can watch the video there. And this video will be uploaded by Tanessa shortly once we've finished this session. How do you get additional compile information? So the compiler information, if you make an error, and I'm actually going to make an error just to show you what happens. Let me skip a semicolon here, okay? Compile, and you can see that I've gotten an error. It says here at line 20 and character space 1, expected a comma or semicolon before void. What does that mean? That it was right here, the compiler was trying to say, hey, I'm trying to understand what you're doing here, but really, I was expecting you to give me a semicolon or a comma. Here you go. Let's try again. And now it compiled cleanly. I could do something like this. See the word letter? Well, I'm going to misspell letter over here. Compile again. And take a look at this. It says letter was not declared. Okay, it may not be there, but guess what it does right? Suggested alternative. Hey, did you mean to say letter with double L? Because that's what I know you have. Compilers are very smart, sometimes too smart for their own good, but definitely smarter than us in many cases when it comes to compiling code, because that's their job. It compiles okay, right? I could do something like, I'm going to miss a single quote there. Let's see what it says. You can see that it says expected, and it says right over here, it's pointing to the error. Now, if you take a look at this, it's giving you some errors at different points in the code. And sometimes understanding the compiler error down here is really, it's a debugging job in itself, because it's giving me so many different errors. What happens is this one missing quote made the compiler think a whole bunch of things. Here it is thinking, oh, I was expecting a semicolon. Well, there is a semicolon or a parentheses. It's like, that doesn't make any sense. Sometimes you got to figure out what is the original error before you try and understand some of the others. So if I fix that one message, that one quote, it compiles okay. This is part of practicing and learning with it. Okay. So just a reminder again, the Tinkercad, sorry, not Tinkercad, the Sparkfun Tinker Kit, right, is what we're using. And if you want to, if you click on this Sparkfun Tinker Kit getting started, this is what we're going through. We're going over the activity. So last week, 2 weeks ago, we went over up to here. Next week, we took a break this week and learned a little bit about the Arduino language. We're going to do the potentiometer and the photoresistor, so you can read ahead if you want and see what those are, and come prepared for it. Or if you don't have the kit, don't worry about it. You can come and watch, and we'll do these two together. And my hope is, depending on how complicated some of these are, I'll probably be doing 2 up to 3 in each session, so that we're not going for, like, months on end, that we'll be able to do it in a reasonable amount of time. Okay, so thank you guys. I appreciate you coming in. I hope to see you guys in 2 weeks. And in the meantime, if you have any questions, my email is right there. And don't forget the GitHub page for all the code, and including the slides for the talk today. And I will upload updated slides with the corrected code as well. Thank you very much. Talk to you guys in 2 weeks or over email. Thanks, Janessa.